I'm here today representing a few broadcasters in the UK, and we got together just before Christmas and we got round the table and we started discussing what would make a really good idea for a project next year. And we came up with lots of ideas, but at the end we really honed in on a concept, and that was software-defined production. And what that is it's really dynamically moving media processing stages between the cloud and on-premise compute, and stripping software away from hardware. And we're doing this a lot in the cloud, so we can move vision mixers from one region to another dynamically. But what the task is it's how do we really do that in a bandwidth constrained location at the event? So how can we then move the vision mixer from the cloud down to the ground? So what the aim is, it's really to build a distributed edge and cloud computing network between the cloud and the ground for a live sporting event. And it's the ability to really geographically move media processing stages without the user knowing as well. So the operational team can be sitting in their production facility, and we've got compute in the cloud and we've got it on the ground, and they don't know where media processing stages are running. And then suddenly, if the bandwidth changes, we can then drop the vision mixer down to the sporting event and then backhaul a single produced feed up to the cloud or into our central hub. So this is an extremely big challenge to orchestrate all of that software provisioning and moving it from the ground to cloud. So really an aim of this is to really kind of push interoperability between software vendors to make that easy. And it's really the simple little things like licensing models. Like how do we have a common licensing model where the first thing we do isn't to send an email to a vendor to get a license. So talking a bit about the bandwidth constrained scenario, I'm now going to hand over to my colleague here, Ian.
Thank you, Jonathan. So some of you have been involved in the accelerators before will recognise versions of this drawing where we've looked at remote production, particularly using 5G, and then last year we were doing work with low Earth orbit satellites in the remote production one. And there's a number of things that we can now achieve because of the IBC accelerators. When we look at what we are now, we've got some sort of 5G private network, the stuff that Bob was talking about earlier, the stuff that we've been deploying, but we've still got a lot of challenges in the low latency space. We've looked at sort of LEO and the constrained capabilities, but if we truly want to deliver remote production, there's a number of functionalities that Jonathan's going to touch on in a minute that we need to run closer to the production scenarios, but also be agnostic a little bit about where we run them in the cloud or the edge, or wherever we want to run them over the network. And by doing that, we really want to focus in on this kind of production architecture that enables us to run these software functions. And it shouldn't really matter where we run them, as Jonathan says. We need to split the kind of people out from the functionality. So we're really interested in looking at that and then also measuring what we can achieve from sustainability, but also what are the minimum network constraints that we can put on these. It's quite easy if we go to a big stadium and we've got a 10 gig pipe out, but actually if we're in the middle of nowhere and we've only got low Earth orbit or bonded cellular or something like that, well, what are the bits in the toolbox that can deliver that? So over the past few months, we've highlighted a sort of number of areas where we think there are challenges, but we've also come up with this kind of set of requirements. So I'm not going to go through them all now because it's time limited, and I think we're the only thing standing here between exercising your lungs in the conversation. So I'll hand back to Jonathan, who can sort of talk about some of the details and some of the things that we've thought about where best to place it.
So this next slide is a visual representation of your typical remote production scenario where you've got a big pipe connecting to the event location and connecting to the cloud or your big broadcast facility. And you can really structure applications in this way. So you have all your big, heavy media applications in the cloud or in your production facility, and you can just backhaul all the camera feeds over your big pipe in the middle. We know that that works really well, but not every production has the finance to have a big pipe. So what happens when that gets reduced into a very small bandwidth? So this could be 10 megs in some situations or 50 megs. You suddenly can't do that remote production model. So what we're looking at is to then shift around the media processing applications to make that production work. So what this is doing, you're shifting all the heavy lifting, so the vision mixing, audio mixing, down to edge compute located at the event, and this could be just uncompressed video feeding that media processing block. And then you're then shifting graphics. You could be doing that in the cloud, because that generally works very well in the cloud, what we found out of this. And then you've then got your distribution chains going off into the cloud. So it's looking at intelligently moving that software around to best suit the constraints of production. And no one production is the same. And it's mainly always dictated by the bandwidth out of that location. So what's the innovation solutions that we're really looking to drive out of this? And it really is the creation of a flexible, tailored production software architecture that just lets us move that software around dynamically from the cloud, from on-premise to edge compute. And really imagining a scenario where we're taking our vision mixer out of our big media processing facility and we're actually putting it down at the event, but we're not actually physically moving that big hardware. All we're moving is software and licensing. And what we want to achieve is we really want to detach the media processing stages from fixed hardware. And we really want to understand sustainability advantages in this as well. So we don't quite know how this is going to play out yet, but I think it's understanding what advantages that are going to be driven out from this. So these are the champions that are involved at the moment, and this is the collective for this project that have come together and have really come out with this common software-defined production concept. But what we're looking for in this is really software-based production systems that want to come and work on this and maybe hone their licensing models, or allowing us to take their software and dynamically move it to any compute block, be it in the cloud, on-premise, or at the event. We're also looking for software development people with expertise that have done this already. We all know that you can download something from the internet, license it, and then move it to another machine. So some of these challenges could have already been solved in the IT industry. So we're looking for people with that experience to come in and maybe say this is how that you can do it. We're also looking for cloud vendors as well, because we want to be moving software from the cloud to the ground in a really dynamic way. This leads on to edge compute vendors as well. So we also need edge compute to be deployed to the event. Outside broadcast providers. So we still need people to go to the events to drive all this, but it's not taking the traditional big broadcast truck, it's taking edge compute, and also low latency encoding and monitoring as well. So this is our vision for this, really. We really see it starting to see a future where we're not driving big metal hardware up in trucks to events. We're simply provisioning software over the network and licensing, and when the de-rig happens on the event, we're not de-rigging the whole truck, we're simply just stripping off the software, licensing and moving it onto the next event, or moving it to the next location that it needs to be in. And really detaching the people from the event location brought us remote production, and it brought us all of the advantages that come with remote production. So what we're looking to do here is we're looking to separate the software from the hardware and really see what advantages that we can drive out from that approach.
Thank you very much.
Excellent.